Okay, this lesson is for Tuesday, October 11th, 2011. Um, Today we're going to review the lab from yesterday on freefall acceleration, so we're going to conclude that lab. We're going to do that by graphing our data and answering some questions, and you can get those questions by going to this link here on the side. After that, we're going to make some time to review the process for writing a formal lab report. You're all going to be responsible for typing a lab report on this freefall lab that's going to be due on the 21st, which is next Friday. So make sure that you pay really close attention to the information we review on writing a formal lab report. And you can get that information if you lose your paper from this link to the side here. All right, so let's go ahead and get started by taking a look at, just review what we did yesterday on Logger Pro, and then we'll get to these questions and discuss where you're going to be answering them and how I expect to see those answers. So let's go ahead and look at the lab we did yesterday. You'll remember that we used the Logger Pro software, and we dropped a little soccer ball from a certain height that we actually measured by using the steps here and then a meter stick at the top. So let's go ahead and take a look at what we did. Okay, so again, we dropped the ball and we used the Logger Pro software to help us get some data points for that ball. We set a scale, we made an origin for that, and we got a nice little graph for position in the y direction, the vertical, for time. So you could see the ball started at a certain height up here, and as the ball fell down from that height, we got different data points showing that fall. Now, what you're going to be responsible for today is going back and using some of that data that we calculated. I'm sorry, I got off this page, but the data right here that we had obtained. Remember, I asked you to get odd numbered data points, so 1, 3, 5, 7, 9. And we're going to take that data for time, position, and the y-axis, the vertical, and then the velocity of the object as it went down. And we're going to go ahead and answer some questions on it. So the first question says that you need to plot your data from the lab we conducted on the graph paper that is included with this handout. You're going to be plotting a position versus time graph and also a velocity versus time graph. You need to list any points here that you feel may be mistakes and explain why you feel that they could be errors. So what we're going to do here is go down and we're going to use that data that we have, and you're going to be plotting your first graph here on the first piece of graph paper. You're going to want to make sure that time is on the x-axis and position is on the y-axis. Make sure you show your units. Give the graph a title at the top. Remember, your title should also include whatever variables are being used in the graph. Make sure that you use a scale that kind of incorporates as much of the graph as possible. There shouldn't be too much free space. And make sure that you start at the origin 0. You're going to make a position versus time graph on this first graph, and then on the second graph we're going to use the velocity and time data. So the third column, if we're looking at your data table, this will be on the y-axis and time will be on the x. So we'll have velocity right here in meters per second and time in seconds on the x-axis. Same things apply. I need to make sure that you have a title on this graph that includes both variables in it and a description of what was taking place for the data. You're also going to want to show, again, as much of this graph being used as possible. Shouldn't be too much free space, so select a range on your axis that includes as many of your data points as possible. Okay? So that's the first question. You're just going to be graphing the stuff. Any data points that look kind of awkward, your position versus time graph should look kind of like this. Now, if you end up with a data point that is just completely off, so let's just go ahead and show a data point that would be way off. If you had made a mistake here and you showed a point that was off to the side, for example, on your graph it might show up off to the side over here or not really in line with everything else. And when you graph that, you'll actually see in your graph that those points are not in line with everything else when you graph it. So whatever points you have that don't kind of make sense, you'll want to make sure you list those in number 1 up here. For number 2, it says, what can you infer from the curve of the position versus time graph? So once you actually plot your points, I need you to go ahead and explain what that curve on the position versus time graph means. For number 3, you're going to be calculating the slope of the velocity versus time graph. So this is going to be the second graph you make. Make sure you show your work. So you're going to want to show the point slope formula. We've used it in many labs up to this point, so you should know it. It's just y2 minus y1 over x2 minus x1. And you'll show your work here for that. And then number 4 says, if the slope of your velocity versus time graph symbolizes the acceleration of the ball as it dropped, then how does that compare with the acceleration of gravity that we discussed for objects on Earth, which is negative 9.8 meters per second squared? So you're just going to take the acceleration you calculated in number 3 and compare it with negative 9.8 here in number 4. And then the last question is for you to evaluate the methods for conducting this lab. That's going to include, what materials we used, the procedure that we went through for actually getting our data, and then you need to make sure that you have a thorough analysis. So I don't want you just to say, we could use a different ball next time. You're going to want to explain why you think we should use a different ball next time. If you think that it should have been done in a different location, you're going to want to explain why you think it could have been done in a different location. Those are all going to be important parts of number 5. Again, don't just list, make sure you explain yourself and in a thorough way so that I can understand your thinking behind why you want to make those changes to the lab. Okay. Now that kind of goes through the questions that you'll be expected to answer for this freefall lab and the graphing that you'll have to do. The second thing that we're going to go over here is going to be the formal lab report. You are going to have a formal lab report. I know this says due September 9th, 2011. This was the first formal lab report that you had due for this class. This second one, though, is not going to be due on September 9th. It's due on October 21st, so make sure you note that. Again, I'm going to review very quickly some of the things we've already discussed for formal lab reports. I expect you to be concise. The lab report should be thorough, but I don't want a lot of repetition. You're going to want to make sure you write in the third person, so I or we should not be included in this paper. Instead of saying we dropped the ball from the second floor, you're going to want to say the ball was dropped from the second floor. So make sure you write in third person. You want to make sure that you write about what really happened in the experiment, not what should have happened. You can evaluate your methods and experimental procedure later on, and we'll discuss that. But you shouldn't be talking about should or could have. You're going to want to use peer-reviewed sources for research. There's a lot of online journals that you can access that will give you information about calculating free fall acceleration. You can kind of use that as background research if you need to find formulas or that sort of thing. The format for the lab report is going to be to first make sure you have a title page. You're going to want to have the number and title of the experiment. So this is the second actual formal lab report that we do. So I want you to go ahead and put in here lab number 2. It's not the second lab we do, but it's the second formal lab report we do. So lab number 2, and then I want you to give a title for your experiment. Okay, make sure the title is descriptive of the lab we actually did. You're going to want to put any names of lab partners you had there, and then you're going to want to put the date that we actually conducted the experiment. So that'll be the title page. You're going to also write an abstract. The abstract should be 1 to 200 words, no more than a paragraph, and it basically needs to include about 1 or 2 sentences on these main points: the purpose of the experiment, the key results, the major points of discussion, and the main conclusions for the lab. The purpose of the abstract, remember, is so that a person looking at your lab could read the abstract and decide if it's important for them to read the remaining part of your experiment. The experiment that you conducted may or may not be applicable to the information they're looking for. So this is kind of a way for them to briefly look over what went on in the lab and decide if they actually wanted to continue reading your lab report. The introduction is going to be where you basically write down the purpose or the objective of the experiment. Make sure that you express that clearly in 1 or 2 sentences. So the example here says the purpose of the experiment was to determine the percentage by mass of acetic acid and vinegar using acid-base titration. The purpose is also sometimes written as a separate section from the introduction, so it doesn't always have to be as listed in it, but I would like for you to do it in this case. You're also going to want to put any background in theory, so any background that you've learned about free fall acceleration, where some of the history in developing this came from. And then a hypothesis, kind of what you expected to happen in the experiment. For us, we're actually trying to see if the free fall acceleration was negative 9.8 meters per second squared. So you're going to want to address that in your hypothesis, that you would have expected to see that. The materials and methods will be the section that is basically where you're going to list the equipment that was used. You can usually show it as a bulleted list, and make sure that it's complete and accurate for all the things that we actually used that day. So if you needed a computer, if you needed the Logger Pro software, all that stuff should be on here. If we had a more complex setup, like you may have seen in chemistry for the titration of something, or if we had a really complex setup for calculating the speed of stuff, we could actually graph that, or draw it so that people could see it at this section right here. The experimental procedure section is going to be where you put step by step exactly what happened. Basically, the important thing here, and it says here, a good rule of thumb for writing complete but concise experimental procedures is to include enough information so that others who read the report would be able to duplicate the experiment at a later date. And by duplicate, they mean that they could do exactly what you did, stand in the same place you did, drop the ball from the same height. So all that kind of information needs to be put into experimental procedures so that someone could exactly replicate what you did in class and see if they got the same results. Okay, the results section of the formal lab report will be where you write down any raw data you have. So in our case, you're going to be showing your data table here. You need to make sure that you highlight important results in verbal form. This is important. You should write out, if you have a data table, that's fine, but you should write out any important results. For example, an important result for the velocity time graph would have been the slope of that velocity time graph, because that actually gives us the acceleration. You're going to want to also show any calculations. You guys actually did do a calculation for getting the height of the drop, and we basically took the number of steps on the stairs and we multiplied by the height in centimeters, and then we added the height at the top of the stairs from the floor to the rail, which for some of you was around 112, 113 centimeters, depending which class you're in. And from there we converted to meters. So you'll want to show all that stuff and make sure that you are as close to significant figure rules as you can in your calculations. The discussion section is the most important part because you're going to kind of be tying everything in. The main question to be addressed here is, what is the significance of the results? So in our case, we wanted to see if the free fall that we calculated using Logger Pro would be close to negative 9.8 meters per second squared, which is what I told you the acceleration for the objects on Earth was that we were going to use. So I want you to compare your expected results, the negative 9.8 meters per second, with what you actually got in the experiment. So that would be the slope of the velocity versus time graph. I want you to explain any experimental error. So if there are any errors in the calculations, one of the things that you could probably discuss is the fact that when you're actually plotting the points here in Logger Pro, that was an eyeball measurement because you're looking at the ball, and for a lot of us the ball was really hard to see because we used a soccer ball and it was small. So a lot of you had a little bit of trouble plotting exactly where that ball was, and that could have definitely added to some experimental error. You want to also explain how the methods could be improved. So ways that you could improve the experiment might be, changing the materials up, what kind of ball we used, where we did the drop. Those are all things you could make sure that you introduce in the discussion section. And then again, explain the results in terms of the purpose. So did the results kind of give you some confidence that negative 9.8 meters per second is actually the acceleration of this ball? Okay, and then relate the results to those of other similar experiments. You can look online and do some research for this, and you might find some other experiments similar to the one we did, and you can compare the two. Conclusion section is only going to be 1 or 2 sentences that basically summarize the definitive conclusions for the results. So you're just going to basically here address in the freefall lab whether our calculated experimental acceleration for gravity was the same as the negative 9.8 meters per second squared that we should have theoretically gotten. Okay. That concludes the formal lab report and what I'm going to expect to see in your formal lab report. This is online. We're going to be having a class setting class that we review, which is in front of you right now, but I don't want you to take that home. If you do need to review this at a later date, it's going to be important for you to come back online to the weekly agenda for Tuesday and access it here on this link. All right, and again, just a reminder, every lesson that we do is posted on YouTube. If you do have access and permission from your parents, it's a very good resource for you, and I suggest you use it. Again, it's not required for this class. It's just a supplementary resource for you in helping you understand the material. All right, that concludes today's lesson. I appreciate you watching.